Hi and welcome. I hope everyone is okay. Now in this lesson, uh, we will solve the question from the last lesson. As you remember, we had learned the PDF probability density function, and then we will pass the other topic. Okay, now we can start. A continuous random variable x has PDF fx given by like this. Show that the median value m is given to m square minus 24m plus 43 equals to 0. Okay, now as you remember that in the on the PDF graph, for example, our graph let it be such this, for example, like this, and the median point, the PDF graph, and the median point let it be here, for example, the median, and under the PDF graph, the median point separate the two area, and this area is 0 point, it should be 0.5, this area should be 0.5, and let it say the median point is m, because they said to us the median value is m, and it should be this area, this area 0.5. So the median, for the median, the integral to from 1 to m fx dx should be 0.5 or 1 over 2, because our x value our x value is beginning of the 1. So our integration, the lower boundary should be begin 1. Okay. Now and the if I go on for work out the integration, and 1 from 1 to m, 2 over 21 multiply 6 minus x dx should be 1 over 2, or it's also 0.5. And I can say that 2 over 21 multiply the integration from 1 to m, 6 minus x dx should be 1 over 2. And maybe I can rearrange, and I can take the 21 is here to here, and 2 I can take the 2 like here. So it should be the integration from 1 to m becomes 6 minus m dx equals to 21 over 4. Okay, now I will figure out the integration. So 6 integration is becomes 6x minus x integration x square over 2, and from 1 to m it becomes 21 over 4. So it's like 6m minus m square over 2 minus 6 and plus 1 over 2, it becomes 21 over 4. And this it should be 6m minus m square over 2. It means minus 11 over 2, and I want to carry these number different side of the left side of the equal sign. So 21 over 4, it becomes 0. And then I want to rearrange these equations, and negative m square over 4 plus 6m and minus 42 over 4 equals to 0. If I multiply to negative 4 both side of the equation sign, equal sign, and then becomes m square minus 24m minus plus 43 equals to 0. And then they set to us 2 m, but I want to rearrange our equations, the situation, and I checked my process, and then 2 m square minus 24m plus 43. Okay, now I could find my mistake, and this is 2, but I have written 4, so it's 2 and 2 and 2. Okay, now our equation is 2m square minus 24m plus 43, 2m square minus 24m plus 43 equals to 0. Find the value of m corrected to decimal place. Okay, now we will solve this equation, and I want to divide it by 2 both equal sign, and divided by 2 m square minus 12m plus 21.5 equals to 0. And I rearrange the equation. M minus 6 square minus and 36 minus 21.5, and becomes 5 4 1 and 14.5 equals to 0, and m minus 6 square equals to 14.5. And I want to look at the result, the equation for using the short time, and m becomes 6 plus or minus the square root of 14.5, but please notice that our m value should be between 1 and 4, so our m shouldn't be 6 plus the square root of 14.5, should be 6 minus the square root of 14.5, and the approximately value is 2.19. And please notice that our m value should be between 1 and 4, so I didn't take the m 6 plus the square root of 14.5. I should take 6 minus the square root of 14.5. Okay, now we can pass the other topic. Our topic about finding the expectation and variance, but now we will study on the PDF or probability density function, finding the expectation and variance. The following probability function is modeled by the continuous random variable x, whose PDF fx is given by like that. We want to find out the expected mean, waiting time, and the variance. With discrete random variables, please remember that in discrete random variables, to find the mean, we calculate like this. The expectation is the sum of all x value multiply their probability. We had computed the expectation like this in the discrete random variable, but our PDF or probability density function is not discrete random, is not discrete function. Our function is continuous function, and we have continuous random variables. So in continuous random variables, all exactly value probability of exactly value 0 for all specific values of x. So it's not possible to use this formula as it is given. Okay, and for example, we have a probability density function, and its graph is here. If we find the probability of a very small interval nu x on the graph, this would be a very small strip, approximately a rectangle with width nu x and height fxx0. So if we want to expectation, for example, we should take x0 and this point x0 x0 plus xi, like this xi, and we should compute to this area, and this area gives us expectation, the expectation of between x and x plus xi. So this area is fx0 multiply x cx. Hence, using the formula for the mean of x, like the integration from negative infinity to positive infinity, x multiply fx. And if we want to figure out the variance, and please remember that variance formula, our variance formula is, for example, about the the expectation, excuse me, that yes, and the expectation x kare x square, the expectation of x square minus the expectation of x square gives us the variance. So in the PDF, on the PDF graph, the expectation of x means the integration negative infinity to, from negative infinity to positive infinity, x multiply fx dx. This formula gives us in the PDF expectation value, and the variance formula is, as you remember, the expectation of x square minus the expectation of x square. So the integration from negative infinity to positive infinity, please notice that x square multiply fx dx minus expectation of x square. So the integration from negative infinity to positive infinity, x multiply fx dx square. Okay, so we have two formula, and the first formula about expectation of x, the second formula about variance of x in the probability density function. And I want to repeat these formula uh, because I want to learn strongly. I want you to learn strongly. The expectation value is the integration from negative infinity to positive infinity, x multiply fx dx. The variance, negative infinity from the negative infinity to positive infinity, x square fx dx minus negative infinity from the positive infinity, x multiply fx dx square. It's also the same, the variance formula, but now in PDF, for PDF we use integration. Okay, and on this function, we will find the expectation and variance. The first time, the expectation of x, as you remember, our boundaries is 0, between 0 and 6, because the other value, our function is 0. So 0 to 6, x multiply fx dx, and from 0 to x, x multiply x square over 72 multiply dx, and 1 over 72, the integration from 0 to 6, x cube multiply dx, and I want to go on here, from here, 1 over 72 multiply x to 4 over 4 from 0 to 6. So 1 over 72 multiply 6 to 4 over 4 minus 0. And it becomes I want to look at the result of the process, because I want to use short time, and it becomes, the expectation value is 4.5. Okay, the 4.5 means our expectation. And the second one, we want to find the variance. Our variance formula is, as you remember, the expectation of x square minus the expectation of x square. So the integration from 0 to 6, x square multiply fx minus from 0 to 6, x multiply fx dx. I shouldn't forget, and and square. Okay, and our function is x square over 72. So from 0 to 6, x square multiply x square over 72 dx minus from 0 to 6, x multiply x square over 72 dx square. And this process is excuse me, that 1 over 72 it becomes x to 4. So x to 5 over 5 from 0 to 6 minus, please remember that shortly time ago we had found the expectation of x also, and it means 4.5, and I can write 4.5 instead of this process, 4.5 square. And our variance is 1.35. Okay, now we have one more example about finding the expectation and variance. The time in minutes taken by students to answer a question in a multiple choice test has a PDF FT as follows, like this. Work out the mean and variance of the time taken. Mean also the expectation of x, and our boundaries is 1 to 4. So the integration from 1 to 4, x multiply fx dx. So from 1 to 4, x multiply, but our value it's called t, so I should write t multiply ft dt. So t multiply 1 over 99 multiply 40 minus t square dt. Okay, and it means 1 over 99, the integration from 1 to 4, it means 40t minus t cube and multiply dt, and 1 over 99 means 40t square over 2 minus t to 4 over 4 from 1 to 4. Okay, I want to result of this process because I want to use very short time. Our result 17 over 44 to 17 over 44. Our expectation value is here, and then we want to find the variance. And please remember that variance formula, our variance formula, the expectation of x square minus the expectation of x, and it means the integration 1 over 4 x square multiply fx dx minus from 1 over 4 x multiply fx dx. But our values called t, so we should use the t letter, and then from 1 to 4 t square multiply our function is 1 over 99 multiply 40 minus t square dt, and from 1 to 4 t multiply our function 1 over 99 multiply 40 minus t square dt. 1 over 99 40 minus t square. Okay, and we should use the expectation value square. Okay, for finding the variance. So I want to rearrange the integration process, and 1 over 99 and from 1 to 4 4t multiply t square minus t to 4 dt, and please remember that we had found the expectation of x. It means 2 17 over 44 and 105 over 44 square. And if I take the integration, 1 over 99 multiply 40 multiply t cube over cube minus t to 5 over 5 from 1 to 4 minus the expectation square 105 over 44 square. And I want to result these process. Look at this result. 1.35 1.35. Okay, excuse me that 0.723 0.723 0.723. Okay. Okay, now we have one more example, worked example about mean or expectation and variance. The arrival time x of a taxi is a continuous random variable x whose PDF is given by like this. The taxi firm states that on average a taxi will arrive within 5 minutes. In this statement, true or false? The taxi firm states that on average a taxi will arrive 5 minutes, within arrive 5 minutes. So if taxi firm states say true, the expectation value should be less than or equals 5. But if the expectation value isn't less or equals than 5, they had set to false. They had set false. Okay. Now we should find the expectation value. So our expectation value, as you remember, negative infinity, from negative infinity to positive infinity, x multiply fx dx. So our boundaries, firstly between 0 to 5, and from 0 to 5 x multiply x over 25 multiply dx plus, and from 5 to 7 1 over 5 multiply dx plus, and lastly 7 from 7 to 8 8 minus x over 5 dx. Okay, should be less and accused than 5 if taxi firm say true. Okay, and 1 over 25, this it becomes x square, and x square integration is x cube over cube from 0 to 5 plus 1 over 5 multiply x from 5 to 7 plus um, uh, 8x over 5 minus x square over 2 over 5 becomes 10 from 7 to 8. Okay, and then 1 over 1 over 25, 125 over 3 minus 0 plus 7 over 5 minus 5 over 5 plus 64 over 5 minus 64 over 10 minus 56 over 5 plus, because 2 minus 2 negative becomes positive, 49 over 10. Okay, and I want to look at the result for using the short time, and it becomes okay. Now I'm look at these process. Okay, and it means 4.8. So 4.8 minutes 4.8 minutes means the taxi will arrive within 5 minutes. So expectation value for point minutes, and taxi firm say true, and it should because of the less and accused than 5, the taxi firm say true. Okay, now so we finished the chapter 3, and the next lesson we will pass the other chapter. The other chapter is called sampling, chapter 5. And now our lesson finish. So have a good lesson and have a good day.